Okay, so let's do 7.1. It's a pretty short chapter or section. So, oh, screen. All right. So we're talking about decimals. Decimalization, connections between fractions and decimals. And so decimal comes from the Latin decim, meaning 10. Decimal number system has its base number 10. So we can represent this number 12, the 0.61873, as this. It's 1 times 10. So we're talking about place value here. So that 1 is in the tens place. And then you have the 2 in the ones place. So it's 1 times 10, 2 times 1. And then this is over 6 plus 6 over 10 to the first, 10 to the second, 10 to the third, 10 to the fourth, 10 to the fifth. So read this 12 and 61,843 hundred thousandths. So if you're going this way from the decimal, this would be ones, and then tens, and then 10 squared, 10 cubed, etc. Where over here, it's 10 to the first and the denominator, and then over 10 squared, and then over 10 cubed, and then over 10 to the fourth. So one way you're multiplying by powers of 10, the other way you're dividing by powers of 10. So each place of decimal number is power of 10. So we say and when we get to that decimal place, this is ones, tens, hundreds, we're counting this way. Here, this would be the tenths, hundredths, thousandths, 10,000ths, 100,000ths, etc. Suppose that along is the base 10 blocks that represents 1 unit, then the cube represents 1 unit. So they're saying if this whole thing is 1, then if you take part of it, that's 1 out of 10 pieces, that would be 1/10. So this is 2 wholes, and then 0.235. This is an interesting way of converting. So what they're doing here is they're saying, how can I break this up into power of tens? So 25 is the same as 2 times 10 plus 5. And then I can break that apart and say I can put the 2 times 10 over 10 plus the 5 over 10. So I get 2 plus 5 over 10, and 5 over 10 is 0.5, or 1/2, which is also known as 0.5. It's quite easy, though, to just say, basically, if it's over 10, you're going to put the decimal here. If it's, oh, sorry, oh my goodness, not there. 1 over from the count 1. So imagine the decimal's here, and then you move it 1 back, so 2.5. Hundredths, you're going to move 2 places. So imagine your decimal's here, you move it 2 back. So here, we are going to go 1, 2, 3, 4 back. So whatever number of zeros you have, that's, you're dividing by that. You're dividing by 10, so it means you move decimal over 1. Here you're dividing by 2 tens, 10 squared. So you're going to divide, you're going to move over 2. You're dividing by 4 tens, or 10 to the fourth. So you're going to divide, you're going to move it over 4 spots, which gives you that 0.0205. This is the kind of different way to explain it. So 2 to the 6th, they're trying to get it to be over some power of 10 in the denominator. And so we know 2 times 5 is 10. So we multiply by 5 to the 6th on top and bottom. So we can group and say, oh, that's 10 to the 6th. And then you can move the decimal over 6 places. So if it's here, we're going to go 1, 2, 3, 4, 5, 6. So that's how we get 0.109375. Again, with this guy, we want to be able to have 10 here. So if I want to be able to group these, they need to be both to the 4th power. So I'm missing 1, 2, because if I multiply by 2, I'll have 2 to the first. This 2 cubed together, that's 2 to the 4th, which is why they did that here. So now I have both 2 and 5 raised to the 4th. So I can group them together, which gives me that 10 to the 4th. So again, then what are we going to do? We're going to move over 4. So if I'm here, I'm gonna go 1, 2, 3, 4. That's why there are 3 zeros in front of that 2. Similarly, so 5 cubed is 125. So then we'll multiply by 2 cubed on top and bottom. So I can group these and say that's 10 cubed, and there's 8 on top. We move on to 3. 1, 2, 3. So that's why it's 0.008 or 8 thousandths. This one, 25, is 2 times 5 cubed. Now I want this to be 2 cubed. So I need to multiply by 2 squared to make it cubed, but I have to multiply by that on top and bottom. So we get 28. And then you can group the 2 and 5 together and say, oh, that's 10 cubed, which is 1,000, but power to 3, I'm going to count over 3. Ready? 1, 2, 3. So that's how we get 0.028. Decimals that can be written in only a finite number of places to write the decimal are called terminating decimals. So a rational number, the terminating decimal, if the prime factorization of the denominator contains no primes other than 2 or 5. So this can be written because it has only 2. This is only 2 and 5. This is only 2 and 5. So that means that it's a terminating decimal, which means it stops. Whereas these are going to be repeating decimals, because if I was to factor out 18, 18 is 9 times 2, and then 9 is 3 times 3. And so the prime factorization is 3 squared times 2, and this factorization is not only 2s and 5s. So that means it's going to be a repeating decimal. Same here and same there. Because the 2 and the 5, remember, that gives you that 10, since we're in base 10 system. The terminating decimals look easily lifted on a number line because it's represented as a rational number. So it's easy to see where it would be. Compare 0.67643 and 0.6759. So if we line them up by place value, we're going to see this is the same, this is the same, and then who wins here? This guy. So then that means that guy is bigger. So that's it for the decimals. Fairly straightforward. As always, please reach out if you have any questions. I'm happy to answer.